Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we're going to work on composite functions. And then the question begs, what is a composite function? A composite function is formed when one function's output becomes the input of another function. So I repeat, a composite function is formed when one function's output becomes the input of another function. So we're going to take a look at these three big examples, and then we're going to show you a true composite function right over here. But let's just take a look at our introduction, right? And so when you see composite functions, okay, they can be in the form of y equals mx plus b, because right here you see this function of x. See, the function of x, as is seen right here, is the same as y, right? So we're going to have to get used to making those two terms interchangeable. Function of x is the same as y. And so all it's saying is this, that for every x value that we plug into here is going to come out with an outcome. All right, and I'm going to show what we mean by that with a simple number. And so let's take a look at 1 as our x value, right? And so whenever we see an x, we're just going to plug in a 1 for our first big example. And so we can say right here, y is equal to 2 times 1 plus 4, or the function of 1 is equal to 2 times 1 plus 4. Again, we're just plugging in 1 wherever we see an x. And so right here, we can say this right here, the function of 1 is equal to 2 plus 4, which equals to 6. So the function of 1 is equal to 6. In other words, y is equal to 6. Now let's go ahead and plug in another value for x. So let's say our function of x in this case is function of -5. So that means whenever we see a -5, we're just going to plug it in wherever we see an x. And so here's what we have right here. So we have the function of -5 is going to be equal to a -10, because 2 times a -5 will give us a -10 plus 4. And of course, our answer will be -6. And so the function of -5 will equal to -6. In other words, y is equal to a -6 right here. And let's say, for example, we have g of x, same thing. We can say that g of x is equal to y. And so let's say g of x is equal to 4x right here. And so now what we're going to do is we're going to say, okay, g of 4, which means that wherever we see an x, we're just going to plug in a 4 right here. And so as you can see right here, g of 4 is equal to 4 times 4, which would give us 16. So g of 4 is equal to 16, letting us know that g of 4 is equal to 16, or y is equal to 16. And let's go ahead and plug in -3 as an x value right here. All right, keeping in mind that we have to multiply it by 4. So we have g of -3 is equal to 4 times a -3. And so we know that g of -3 is equal to 12, right? Because 4 times a -3 will give us a -12. And that is the same as saying y is equal to a -12. And here's why it's important. Because again, going back to our original definition, and I'll repeat that, a composite function is formed when one function's output becomes the input of another function. And that's what we're going to do right here for this. Okay, so let's say again, we have function of x is equal to 2x plus 1. And let us plug in -3 as our x value. And of course, function of -3 is equal to 2 times -3, because we're just going to plug in a -3 wherever we see x. And so we have 2 times a -3, and then we're going to add 1 at the end. And as you can see right here, function of -3 is equal to a -6 plus 1 will give us a -5. And of course, function of -3 will equal a -5. All right, now watch this. Now, what is g of f of -3? Okay, oops, now it gets a little bit different, right? So now all we have to do here in this case, because this is the output, we're just going to plug in that output right here. Okay, so we have g of x is equal to 4 times x, and that's all we're going to do right here. So g of function of -3 is going to be 4, right? This 4 times this -5, and the answer will equal to a -20. So g of g of f of -3 is equal to a -20. And I'm just going to repeat that just in case if I made a mistake in pronouncing it. This is g of f of -3. All right, that's what it is. And so again, g of f of -3 will give us a -20. Now, your teacher may have you do this, right? Your teacher may have you substitute this whole value right here for this x, okay? And so we're going to prove that -20 is correct. So we have g of function of x is equal to this 4, okay? And we're going to plug this entire value in for this x right here, 4 times 2x plus 1. Okay, and so all we're going to do in this case right here, right, because we know that we have a function of -3, we're going to plug in a -3 wherever we see an x. We can do that right here because we have to do that. And so now when we do that right here, g of function of -3 is going to be equal to 4 times the quantity here of 2 times a -3, and then we're going to add that 1 to it. And as you can see, we have g of function of -3 is equal to 4 times a -5, which will give us a -20. Okay, yeah, I've been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at things or replay this video as many times you need to gain a deeper understanding of how composite functions work. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.